Okay. Hi everyone. So today we'll be discussing about Venn diagrams, and let me just tell you in a simple concept. This page, whatever the page you have, let me just make you to understand in a simple manner. Okay. Now you see a rectangle over here, right? So this rectangle you should call it as universal set. What you call it as? Universal set. Okay. Now let us talk about events. Okay, events are represented with the sort of circle. Okay, na rendu gajulu. Huh. Okay, so so this event, what do you call it as? This is an event. You can call it as probability of A. What do you call it as? Probability of A. Now let us talk about one more event. Okay, Ta-ta-nine. Okay, you got one more event, and this is called probability of, like, this is an another event. Okay, now you might have a question, what is an event is all about? Now, event is nothing but see, there is something happening, and let's understand that students who are playing chess. Okay, these are chess playing students, and these are who are these football playing students. One is indoor game, and the other one is outdoor game. Okay, so, yeah, this is an indoor game and this is an outdoor game, and this is called universal set, the rectangular part. This is a probability of event A, and this is probability of event B. I hope you understood. Now, do you think, now, like, if I ask you a question, okay, let us understand that uh, the ring finger, I mean, this, whatever I'm tapping, this is chess, this is football, okay? Chess, let us understand there are seven students. How many are there? Seven students. Here it is six students. Six students are playing football. Okay, what do you actually like to play? I really like outdoor games. What about you? Okay, so let's come back to the topic. So this is chess, which are like seven students. These are six students. Now tell me how many are playing football. You will automatically you will say six students. If I ask you how many are playing chess, automatically you will say seven students are playing chess, isn't it? Because this one, right? Now, how many students are playing both of them? Do you see any overlapping between them? No, right? There is no overlap. If I say these are not overlapped with each other, isn't it? A union B. A union B means combined. How many of them are playing both? Okay, both chess and football. How many are playing? No one is playing. Okay, no one is there, right? It is nothing but null set. And these are mutually independent events, isn't it? These is not dependent on each other. This is also not dependent on each other. They're mutually independent events. What do you call it as? Mutually independent events. Now, there might be a scenario, there might be a student like me who likes to play both chess and football, isn't it? Some students will be there who like to play indoor games, who like to play outdoor games. So, what happens at that moment? Let's say one student, and that is me. Okay, I want to play both chess and football. Look at this, there is an overlapping between each other, and one student will be over here, and other student, I'm in both of them, right? I'm in both of them. So here it will become 6 plus 1. How many are there? 7 students are there, right? Here, total how many are there? One student is in common. Here will be 5. 5 plus 1 will become 6. 1 plus 6 will become 7. Okay. The numeric part you might be confused, but just understand the concept that one student is overlapping. Do you see the overlapping? There is this one, the middle part. Okay. There is an overlap between two events. So you should call it as A intersection B. What do you call it as? A intersection B. What is A intersection B? The middle part, whatever the part is there. Okay. There is an intersection between problem event A and event B. So the middle part you call it as A intersection B. I hope you understood the concept. So let us go on and one more thing, you can also call this one is universal set, right? You can also call it as sample space. There is nothing, no deal in it. Okay. So let's move on to the next concept, which is two event Venn diagram. Okay. So if they are not overlapping with each other, what you call it as mutually exclusive events, isn't it? Is there any intersection between them? No, there is no intersection between them. So A intersection will be equal to null. Okay. Now, if there is an intersection between both of them, okay, do you call it as null? No. A intersection B is not at all equal to null. Okay. That means there is a person who is in between chess, who is playing chess, who is also playing football, right? So the intersection between both of them is not is equals to null. Okay. They are dependent events, right? Yeah. Now, so, and one more thing. I told you, right? That there will be one event, there will be one more event, right? So when I say the whole thing, you call it as A union B. Okay, the event A, event B, and the intersection between them, you call it as A intersection B. What do you call it as? A intersection B. A intersection B means ulta U. Okay, do you see here? This is A intersection B. Okay, this is called A intersection B. Now, this is called A union B. What do you call it as? A union B. That means both, all the events are happening over here. So you call it as A union B. What about the empty region? That is nothing but A union B complement. What do you call it as? The empty region, whatever the events are happening, the outside part you call it as A union B complement. How do you write it as? Do you see here? A union B whole complement. There is a small, you can just put a one over there. Okay. So small at the top you have to keep. Okay. A union B complement. Okay. So I hope you understood. Now, how do you get this region? Okay. Now, let me just tell you, the whole thing is like you will calculate it with one. There is a formula for it. To find A union B complement, you have to subtract from 1. So, the formula will be something like this. A union B whole complement is equals to 1 minus A union B. Okay. What is A union B whole complement? 1 minus A union B. That means from the whole set, you are removing A union B. When you remove this part, when you remove this part, automatically you will get the other region, isn't it? That is how they are calculating A union B complement. Okay. Now, so what is the use of all these things? Why we are doing Venn diagrams and all? So to get the outcome of an event, there are three things. Okay. One is you will get the outcome of the events, the number of outcomes you will get, and also you will get some sort of like probabilities. That's the thing. Okay. And also they have represented a small example, as you can see. As you can see, A. Okay, in the A, what you can see, the whole set A, the whole circle A contains 0.4 and 0.3. What is 0.4 plus 0.3? What is 4 plus 3? 7. 0.7. So probability of A is nothing but 0.7. Now look at the other B. How many numbers are there? 0.3 is there and also 0.2 is also there. What is the addition of 0.3 plus 0.2? It is 0.5, isn't it? As you can see here, 0.3 plus 0.2 will give you 0.5. 0.4 plus 0.3 will give you 0.7, right? Now, outside also there is one more, 0.1. Okay, what do you call it as? A union B complement, just now I told you, right? Okay, leave it aside. Now, what is probability of A? Probability of A is 0.4 plus 0.3, which is nothing but 0.7. Now, what is probability of B? 0.3 plus 0.2, which is nothing but 0.5. It's like 0.4 students are only in chess. 0.3 students are both in chess and football. 0.2 students are only in football. Okay, only in football. Now, if I ask you how many total students are there in football, then you should say 0.3 plus 0.2. Isn't it? Right? Now, okay. Probability of A you understood, probability of B you understood. Now, probability of A intersection B. A intersection B means how many are like, there are some students who play both of them, the intersection part. How many are students are playing? 0.3. Automatic answer. You can see in the diagram itself. Now, there is a formula for P of A union B. What is the formula for P of A union B? Probability of A plus probability of B minus probability of A intersection B. That means total how many are there in probability of A, total how many are there in probability of B, and you should subtract the intersection part minus how many are there in both of them. 0.3 are there. So 0.7 plus 0.5 minus 0.3. How much you got? 0.9. Okay. Now there is one more last. Probability of A complement intersection B complement is there. It's nothing but probability of A complement intersection B intersection is nothing but probability of A union B intersection. Sorry, probability of A union B complement, which is nothing but 1 minus A union B. So 1 minus, just I told you, no, you have to subtract this A union B thing, then automatically you will get the other part. The same thing they have done. 1 minus 0.9, which will give you 0.1. Clear with this point? This is what Venn diagrams are. Okay. I hope you understood the concept, and if you have any doubts regarding this video, you can just ping me in my WhatsApp number. I'll just update you regarding it. And thank you so much for listening. Bye bye.